Hi, I'm Paul. We're doing Leetcode must know interview questions. Today's challenge is find K pairs with the smallest sums. Rating, medium. Yeah, this is, I think this is a pretty manageable problem. The challenge is you are given two integer arrays, nums1 and nums2. They are sorted in non-decreasing order, meaning there may be duplicates, and an integer, k. So define a pair, uv, which consists of one element from the first array, one element from the second array. Return the k pairs with the smallest sums. So the smallest sums with one element from the first array and one element from the second array. Now these examples, the arrays are the same size, but I don't think that's a requirement. Okay, so the array length will be between 1 and 10 to the 5th. What is that? 100,000? Okay. The numbers, pretty big range of numbers, both sorted. K, okay, K equal, K, oh, it's less than or equal to the length of the first array times the length of the second array. Not sure why that's interesting. But I don't think that, well, looking at constraint 1 here, there's nothing to say that the arrays are going to be the same size. So let me scoot this over so we can see the whole method signature. Here's the method, k smallest pairs. Input is two arrays of integers and an integer k. And we return a list of integer lists. Let's look at an example. So, let's look at example 1, 1, 7, 11. Numbers 2 is 2, 4, and 6. K is 3. So we need the three smallest pairs. Without getting into how we could figure that out yet, let's just look at the format that we need for the output. It's a list of lists, a list of integer lists. Okay? Now we can talk about how we might get that. Okay, well, the first observation is that because they're sorted in non-decreasing order, if we pair the first element of nums1 and the first element of nums2, that's going to be the smallest sum, okay? So where do we go from there? Well, the next smallest sum is either going to be the first element of nums1 and the second element of nums2, or the first element of nums2 and the second element of nums1. So we could add both of those two. We're going to use a heap here, by the way. Put those on the heap, and then something comes off, and then where are we? It gets kind of confusing to me at that point. What do we add next? So we're going to add the elements to the heap in a little bit different way, but we'll make sure that at any point the pair that could be the next smallest sum will be will be on the heap. All right, so let's do this. I'm going to squeeze this over. How far can I squeeze it? I guess that's it right there. To make sure that we have, well, to make sure, I mean, I hope we have enough space for this. Okay, Let's do it like this. We have a priority queue. The priority queue is going to contain, I guess, well, it's going to contain integer arrays. And what's going to be in the integer arrays is an index from nums1, an index from nums2, and a sum. So we could start like this. And the heap is going to be, it's going to be a min heap based on the sum. So let's do this. The first thing that we can put in there is, let's see. The first thing we can put in there is the first two elements of each array. So we've got nums1, the first element is 1, nums2, the first element is 2. Add them together. That'll be the sum, okay? 3. Then we'll put the index of the arrays. So the index actually is 0 and 0. Okay? Now, what I'm going to do, this isn't the only way to do it, but to me it's the least, confusing way to do it. We are going to loop through nums1 and add every element in nums1 paired with the first element of nums2. So that would be, let's see, second element of nums1 is 7 plus the first element of nums2 is 9. The indexes that we're using are 1 and 0. Okay, next thing we'll add is the third element of nums1, 11 plus 2. The sum is 13, and the indices are 2 and 0. Okay. I guess I'd just say in the implementation of this, we are also going to have to make sure that that the length of nums1 is at least k. All right. Now we are going to take three passes. Well, I should say 3. We're going to take k passes through a loop. Or let's say at most k passes. If the queue goes empty at any point, we're going to have to stop. I don't think it even says here what to do if we run out of pairs. I'll look at that again in a second. But let's do this. Let's take the first element off the heap, and that is going to be this. This has the smallest sum. Okay, here's the index 0, 0. We look up the numbers at those indices, and it's 1 and 2. All right, so that'll be part of the answer here. 1, 2. Okay, and that is gone. Okay. Let me think about this for a second. So what we just took off was 0, 0, index 0, nums1, index 0, nums2. Now the next smallest sum is either going to be at index 1 in nums1, 0 in nums2, which we already have in the heap, or it's going to be index 0 at nums1 and 1 at nums2. So we have to add that to the heap. 0 and 1. So the first number in there is, wait, I'm sorry, no. So we want 0, 0 from nums1, which is 1, and 1 from nums2, which is 4. All right, so the sum of that is 5. Okay, 5. 5. The indices are 1 and 0. All right. Now, that's the end of the loop. So we go through the loop again. Now, we take the first element out of the priority queue. The first element, because it is a min heap by sum, is going to be this last one right here. And the sum is 5. And the indices are 1 and 0. And that is, I'm sorry, I wrote that wrong. It's not 1 and 0. It's nums1 is index 0, and nums2 is index 1. 0 and 1. So it's 1 and 4. Okay, so that goes in the answer. 1 and 4. All right. This is going to come off, but the next smallest number is either going to be, well, the next smallest number based on that index, 0 and 1, it could be 0 and 2. So we have to add that. All right, so this is coming off. And we're going to look at index 0, which is 1, index 2 here, which is 6. That is a 7. We're going to add that to the heap. All right, sum 7. The indices are 0 and 2. Okay, next time through the loop. Again, if we take this off based on a min heap, this is coming off, this one. So that is index 0, which is 1, index 2, which is 6. That goes into the answer, 1, 6. And that's k times through the loop. So that is the answer, 1, 2, 1, 4, 1, 6. And let's look at an implementation. But actually, before we look at the implementation, does it say what to return if k is, well, wait a minute. K, all right. Well, k is less than nums1 length times nums2 length, but okay. It really doesn't say what to do if k is if k is larger than the size of one or both of the arrays. So let's just go ahead with an implementation and see what happens. So first thing we need is a priority queue. It's going to be a queue of integer arrays. We'll call it PQ and say new priority queue. One of the constructors for priority queue lets us send in a comparator function. In this case, our comparator is going to be comparing int. So for each array, what makes one array less than another array? It's the first element, a at index 0, because that's the sum. Okay. Now we start loading pairs of numbers into the array. Again, we're going to load all of the numbers in nums1 paired with the smallest element in nums2. That's how we're going to bootstrap this thing. So for int I equals 0, I less than math dot min nums 1 dot length and k, and then I plus plus. Yeah, so again, if it does happen that k is greater than the length of the nums1 array, we still don't want to go, plowing through the end of the nums1 array. So we got to check that. Priority queue offer. We will offer a new int array consisting of nums1 at I plus nums2 0, and then the indices, which would be I and 0. All right, so we've got the thing primed. We do need to define, actually, you know what, I could just copy the data type from here. We need to define a list to hold our answer. So the answer will equal a new array list. All right. While what? Well, now we're going to start taking things out of the queue. So before we do that, we should make sure that the queue is not empty. Other than that, we're going to loop through it k times. So let's decrement k every time and go to, yeah, that should work. And we'll go through k times. All right. Take an element out of the queue. It's going to be an integer array. We'll call it EL, element, equals q dot poll. First time through, this is guaranteed to be the smallest sum. It's the smallest number in nums1. It's the smallest number in nums2. Okay. And we'll add it to the answer list. It's an array, and we've got to convert it to a list. So let's say arrays as list. What we're going to put in there is nums1 indexed by. Keep in mind that the integer arrays that we have in the queue don't have the numbers from these arrays. They have the indexes from these arrays. So we'll have nums1 indexed by element 1 and nums2 indexed by element 2. Okay. What's next? All right. We have loaded all of the numbers from nums1 paired with the smallest element of nums2. So what is the next smallest sum going to be? Well, we've got these two indices. So the next smallest sum is either going to be the number at element 1 plus 1 with the current nums2, and we already have that in the heap. We have all the nums1 elements in the heap. The other possibility is it could be the same number from nums1 paired with the next element from nums2. And that's what we have to add to the heap at this point. So let's say if element at index 2, that's the nums2 index, plus 1 is less than nums2 dot length, again, there's, well, let me think about that. Yeah, we got to make sure that we're still inside the bounds of the array if we're gonna increment that index. We'll do PQ offer. It's gonna be somewhat similar to this, which I'm gonna copy. Okay, we're going to offer a new integer array. It is going to be nums1 indexed by element at index 1 plus nums2 indexed by element index 2. I'm running out of space here. I'm just going to squeeze that in, plus 1. The indices will then be element at index 1 and element at index 2 plus 1. I hate to see lines wrap. Wrapped. No, I don't like that. All right, I'll just do it like that. Okay, so now again, at this point, we're guaranteed to have the next smallest sum in the heap. So we'll go through that k times. We'll have an answer at the end, and we'll return the answer. I'm going to go ahead and run that. Yeah, I kind of thought that. Oh, okay. What is that? Illegal start of expression on line 15. Yeah, that doesn't look right, does it? Why is there a bracket there? Okay, try it again. File error. It's getting closer. Nums2 dot length. What is wrong with that? Oh, there's another bracket there. Okay. Goodbye. All right. Oh, I said not Q. That's not right. It's not PQ. Not PQ. All right. Let's fix it there too. PQ. I got it right there. All right. Let's go. Nums1. Oh, okay. Line 13. Nums1. The bracket is in the wrong. Okay, no, I'm missing a bracket. Nums1. EL1. Okay. Line 13. And there still needs to be another bracket after it. You know, I guess I'm a little spoiled by IDEs that notify you in real time when you do things like this. Anyway, that's so that is accepted on the base cases. And let me stretch this out a little bit. Let me move that out of the way. Why can't I move that out of the way? Well, all right, let's put it over here and submit. All right. So wow, those times are really spread out. Okay. The only thing I can think of why they're spread out, I don't know. You could put numbers in the array instead of indexes. That would save you the time of looking them up. There's other ways of adding. There are other ways of adding elements or the integer arrays to the heap. I mean, you can kind of add them one, just add the first one and then I don't know. I don't want to get into that. It's too confusing to me to do it that way. So we probably wind up adding more elements than we need to, but it's to me it's easier to understand the solution this way. Otherwise, that's it. It's just it's a min heap, and it's a min heap based on sums, and that's it. So that is it for find K pairs with smallest sums. I hope you enjoyed it. Please feel free to like, subscribe, comment, and see you next time.